Today, we're diving into the secret language of machines. I mean, think about it. From a robot on an assembly line to the thermostat in a smart building, how do all these different pieces of equipment actually talk to each other? Let's get into it, right? You've got a temperature sensor over here, a huge robotic arm over there, and some central control systems somewhere else. They all have to be on the same page constantly. So how do they do it without, getting their wires crossed? Well, the answer is they use a shared language, or what engineers call a protocol. And a protocol is pretty much exactly what it sounds like. It's just like a human language. It gives devices the grammar and the vocabulary they need to actually understand one another. Without these shared rules, you just have a bunch of digital noise. It's the absolute foundation for any kind of meaningful communication. And one of the most important, most foundational languages in the entire industrial world is called Modbus. It was developed way back in 1979, and it became the go-to standard for a simple reason. It's reliable, it's simple, and it's open source, so anyone can use it. But just like any language, Modbus isn't just one thing. It has different dialects, and that's exactly what we're going to explore today. Okay, first up, let's meet the reliable veteran of the family, Modbus RTU. This is the classic, the time-tested version of the language that's been getting the job done for decades now. So what is it exactly? Well, Modbus RTU basically sends messages as simple electrical pulses over dedicated physical wires. You'll often hear about serial lines like RS-485. It's a really direct way for devices to chat using a super compact binary format. There are no frills here, just pure, efficient data. And this really gets to its core identity. It's all about serial communication, connecting devices over distances up to about 4,000 feet. A really key part is its architecture. It operates on a strict master-slave model. You have one master device that's in charge, it initiates all the conversations, and all the other slave devices just respond when they're spoken to. This whole setup makes it absolutely perfect for localized systems where simplicity and cost are the most important things. Now, let's meet the other side of the family, the modern networked evolution, Modbus TCP/IP. This is the dialect that was built for the age of the internet. What Modbus TCP/IP does is it takes that core Modbus language and it adapts it so it can run on the exact same Ethernet networks that connect all of our computers, our offices, and our homes. It uses TCP/IP, which is the fundamental language of the internet, as its delivery system. So the contrast here is really the whole story. Instead of those dedicated serial wires, it uses standard Ethernet. Instead of that rigid master-slave setup, it uses a much more flexible client-server model. And because it's on a network, its reach isn't limited to a few thousand feet. It's potentially global. This makes it the go-to choice for high-speed, really complex systems that need to be able to scale up. Okay, so we've met the two contenders. Now it's time for the showdown. Let's put them head-to-head and really dig into how they're different. First up, the physical path the data takes. Modbus RTU is kind of like having a private, dedicated phone line running between your devices. It's super reliable, but it's totally separate from other networks. Modbus TCP/IP, on the other hand, is like using the public internet. It shares the road with all the other network traffic, but the big advantage is that it can go anywhere that network goes. This is a huge difference in the flow of conversation. RTU is what's called half duplex, which is basically like a walkie-talkie. One device talks, then the other one responds. Over. But TCP/IP is full duplex. That's like a telephone call. Both devices can talk and listen at the exact same time, which, as you can imagine, means a much faster exchange of data. The power dynamic is totally different, too. That master-slave hierarchy in RTU is really rigid. Only the master can ever start a conversation. TCP/IP's client-server model is a lot more democratic. You can have multiple clients all requesting data from different servers. It's way more flexible and scalable. And this isn't just a technical tweak. It was a huge philosophical shift that really unlocked the potential for the kinds of massively complex, interconnected systems we see today. But all of those differences, they're really secondary to the single biggest difference of all. It's not just about the wires or who gets to talk when. It's about how the message itself gets packaged up for its journey. And this image shows it perfectly. Think of a Modbus RTU message as just a raw letter. But a Modbus TCP/IP message, well, it takes that exact same letter, the original Modbus data, and it puts it inside a TCP/IP wrapper. The best analogy is putting that letter into a standard shipping box, slapping on a delivery address, and now it's ready to be sent through the global mail system. So what does that wrapper actually do? Well, first, it adds a new network header that acts just like the address label on our box, telling all the routers where to send the package. And, this is crucial, it drops the old Modbus error checking system. Why? Because TCPIP has its own, much more robust system for making absolutely sure the message arrives perfectly. It's like getting a free upgrade to a more reliable delivery service. So, with all that in mind, how in the world do you actually choose between them? Let's make this really practical. You're going to want to stick with the veteran Modbus RTU if your system is pretty small and self-contained. If you just need a simple, low-cost solution, or if you're working with older equipment that doesn't even have an Ethernet port, RTU is going to be your most reliable and straightforward choice, hands down. But you'll want to go with the modern evolution, Modbus TCP/IP, if you're thinking bigger. If you need speed, if you need to send data over long distances, or if you need the ability to easily add more and more devices in the future, TCP/IP is the clear winner. And if you want the data from your factory floor to talk to the software in your front office, TCP/IP is the bridge that makes all of that possible. And here's a neat little detail that just shows how integrated Modbus TCP/IP is with standard networking. It has its very own official reserved port number, port 502. So when a Modbus device is on a network listening for messages, it's tuned into port 502. It's kind of like having its own dedicated mail slot in the digital world. Okay, this all leads to a really practical question. What if you have older RTU equipment, but you're building a new TCP/IP system? Are you stuck? Is it an all-or-nothing choice? No, absolutely not. And the solution is a really clever little device called a gateway. A gateway basically acts as a translator. It takes that networked TCP/IP shipping box, it unwraps it, and then it just hands the original Modbus RTU letter to the older device. It lets the new and the old speak to each other completely seamlessly. And ultimately, you have to remember that both of these dialects belong to the same powerful language family. This quote really captures why Modbus has lasted for over 40 years. It's a widely accepted, open, public domain protocol that does not require royalty payment. That openness, that's its real enduring strength. So in the end, it's really not about which protocol is better. It's about which one is right for the job you need to do. Whether it's the simple, rock-solid reliability of RTU or the network's power of TCP/IP, Modbus continues to be the language that makes our automated world work. The only real question left is, which dialect is going to power your system?